Yes, sir. Sure, sir.
Thank you. Let me share. So we stop just here. Sorry. So the state space could be discrete or continuous, whereas the I mean experiment. I mean examples also I provided the temperature example, and we'll have more examples also. In fact, the we designed the course such that the tutorials you see that completely will be on examples. I mean examples means real world applications. So during the theoretical content, the examples I'm showing will be again a kind of hypothetical examples, but real world examples we'll see. Real world applications we'll see during the tutorials. So I mean, as we continue that, someone asked a good question about the in an office building when you go when we take a decision to go or cinema hall. You there are a number of seats in a cinema hall is the finite. Suppose the tickets are issued to us randomly. Suppose usually we go to the multiplex, they ask you where you want to sit down. But suppose you don't know. As a suppose everyone gets a randomly they allocate the seat. Then you pick a ticket like a lottery. You go and sit down at the location wherever you get it, and that is repeated over the time. First time you go, second time you go to the cinema hall, third time, and so on. The different locations is the same. Cinema hall could be same, but state space also same. But which state of a state space or which element? So element of a state space is called a state. State of a space. These are very very important because when you in a real world application of medical science or any other sciences or financial markets anywhere you apply stochastic process, first thing you need to understand is what is the state space of that particular stochastic process. So before that, I mean I should have let me wait a minute. Close the yeah. See, this I should have explained in the without the screen sharing. So most fundamental thing when you conduct a real world model building of a stochastic process, first and foremost thing you need to formulate is the state space. What is the state space of that particular application you want to conduct? Be it a medical science, be it a financial market modeling. You are asked to build a stochastic model. That's what some industry or they approached you as a modeler. Your first aim is to what would be the state space? Is the state space is a continuous state space or a discrete state space? That's what you as a investigator first thing you need to decide. They won't tell you. The industry which are sponsoring your project, they won't tell you or they won't know. You as a stochastic modeler need to decide this particular experiment. Then after that state space is decided, how the random variable fluctuates over the time. Like ECG example I gave. ECG is definitely a continuous state space. ECG, the minimum value, maximum value is well defined. Certain value minimum, patient is dead. Certain higher value, the higher blood pressure, patient also might be possible to die. but in between there is a fluctuation. Similarly, the blood pressure. They put some small clip to the individual and they measure the blood pressure. So this is a continuous. So state space, and then each time a patient, the value of a blood pressure measured, that means that is a state and state space. So the discrete or continuous, this is the clinician, the doctor would not know what is a state space, technical term for them. And that's fine. Because you as a modeler, doctor treats patient, you build the model and you collaborate together and then help the doctor, means help the patient ultimately. The fluctuations, how you build a stochastic model, and the random variable changing a value, blood pressure value from 97 to 96 fluctuation or 97 to 70 the fluctuation. Next time when the patient comes to the clinic, what would be the value? That we do not, we are not, the doctor or the modeler would not know for sure, or a value of a stock. So these things, value of a stock, again, stock exchange value, some exchanges they put continuous value, some exchanges discrete value. So you as a modeler, you have to decide whether it is a discrete or whether it is a continuous. If it is a continuous, the state space becomes a continuous. We'll also see the examples, as we saw in the weather example or ECG example or the blood pressure example, they're all continuous state spaces and states within that. So that's how as a modeler, we have decided which is appropriate for that particular experimental setup. So let me continue the slides again. Suppose we toss a coin 60 times during an hour and record the outcomes. Record its outcomes. Even we are recording 60 times, the outcomes are either head or tail, isn't it? These things are not changing. The state space, the values of a state space is not changing. Whatever is predetermined state space, whatever you consider, that remains same, but the outcomes are changing. The state space remained constant, but the values, each time the outcomes x1, x0, x1 and so on is changing. And how do here intentionally I showed it as a 0 to 59, or you can show 1 to 60, either thing is same. Here the state space is also discrete, the time also discrete. So discrete time. Now once we understand the state and the state space, now the process, now random variables are taking values which are discrete, that is head and tail, they're discretely taking the values. And the space also discrete. So this is called discrete time, discrete space. So you're jumping first experiment, x1, x2 and so on. So this is called, this particular experiment is called discrete time, discrete space stochastic model. There are 4 types of stochastic models. As I showed in the beginning, the types of stochastic models are there. So this is one type. Second experiment. So first experiment, the type is discrete time, that is both space and time, both are discrete. Suppose our experiment consists of mixing 2 types of chemicals and measuring the level of chemical bonding. Measure level of chemical bonding at the measuring the next 1 hour. Each time you chemical bonding measure, and then time at the measuring the next 1 hour, you record the time. So the 3 different categories, say high level of bonding, medium level of bonding, low level of bonding, and none. So the experiment is what? Mixing 2 chemicals. your experiment, chemical experiment, some two chemicals you mix and you measure the bonding next 1 hour. During the next 1 hour, you see that what is the level of bonding. And you define predetermined. High means certain level of bonding, high, medium, low, you define. As a experimental this thing you defined, or a chemist has given to you, and you are a stochastic modeler, you want to build a model for that. Now the state space is high, medium, low, and none. That means high level of bonding, medium level of bonding, low level of bonding between two chemicals, and none. Bonding never happened. And time 0 to 60. 0 and start, you're starting within 1 hour. Now in this case, you see that the space is discrete, but time is continuous. Because the bonding might happen continuously or not, none. And the end of the 1 hour, after end of the 1 hour, experiment is done. And middle any time during the 1 hour, you may want to see whether the bonding occurred or not. You may want to see after 30 minutes, 29 seconds, or after 32 minutes, 23 seconds, or 23 point ... seconds. Anytime, just put a stop clock, you see, then you start the clock, stop clock, and you want to see the experimental outcome. So outcomes are each time either high, medium, low, or none. But outcomes are discrete. State space is discrete. Time is continuous. So these kind of experiments are called as stochastic models, which are discrete space, continuous time. So time step is continuous. So that means you can stop the experiment. You can see any time during the experiment. That's called continuous time. And discrete space. So stochastic models which are of discrete, which have discrete space and continuous time. The previous coin tossing, you saw that both are discrete time, space, discrete time and discrete space. They are known as discrete time, discrete space stochastic models. This particular example on chemical bonding is continuous time, discrete space, or discrete space, continuous time. Either you can flip either way. But this is time is continuous, space is discrete. Example 3. So body temperature, as we discussed, some time back, body temperature, blood pressure, they are all, that in that case, the state space, some interval. In a morning, the patient, anytime during this thing, patient hospital or medical setup, patient comes and patient is kept on observation. Patient kept on observation. So at the time of entry, you see that, hospital, they measure as soon as the patient admits in the bed, hospital, they measure the height, weight, temperature, everything. So temperature, they measure and they keep it in the record. And patient want to be observed 24 hours, like COVID time, the patients are continuously monitored 24 hours for the temperature, everything. So let us take example, temperature is measured. Now the state space.
Class लगेगी अभी रुक जा.
I didn't get the question. आप क्वेश्चन को रिपीट करेंगे?
So participants are requested to mute their mics, please.
Oh, mute the mic, okay. हाँ, किसी को क्वेश्चन हो तो आप अनम्यूट करके पूछ सकते हो. So measurement, suppose पेशेंट, आप कोविड का पेशेंट ले लीजिए. कोविड पेशेंट एडमिट होते ही उनका मेजरमेंट आप मेजर कर लो. उसके बाद आफ्टर दैट द पेशेंट, उनको एक दिन का ऑब्जर्वेशन में रखते हैं ऑन एन एवरेज. उसके बाद क्या होता है, let x be the temperature at the time of patient admitted, COVID patient admitted, and y be the time of temperature at the time of patient, say next 24 hours, or at the time of exit of a patient. Here in this case 24 hours I kept observation for 1 day. So COVID patients observation exactly same time next day. Now the state space is what? In the hospital, continuous. previous chemical bonding, high, medium, low, none. In this case, the temperature of a body of a patient in a hospital is continuously, might change or might not change. You don't know because it never, exactly patient. हम लोग temperature measure करते हैं लेकिन 97 degrees or 98 degree, 98.4, but body temperature may not remain always same. Suddenly you suddenly changes, fluctuation hota rehta hai. On an average we say 98.4 is the average temperature of the body, but still our body, we all know that pressure and temperature, they keep on changing every day around the clock. So state space in this.
So I have a query here that is there any constraint over the finiteness characteristic of the state space, or can we have infinite state space also? Like in this case, it seems.
Correct. So in this case, the interval is the state space, not the value. It's not x comma y in a set. If a set is, I read curly brackets, x comma y means it's a closed interval. Patient
Yes,
admits.
right.
Clear?
Yes. So can we have infinite state space also, or is it necessary that every time we would be dealing with the finite state space only?
Good question again. This is the infinite state space also could be there. Unknown. Infinite means you keep on changing, infinitely. Like you saw j equal to in the example j 1, 2, 3, 4 dot dot and so on. Infinitely, the state discrete. They might take discrete values, but the infinite. Suppose you want to the state space consists of, say, winning a 1 rupee each time you play a game, and you might play the game infinitely many times. Anna. So 1 rupee, 2 rupee, 3 rupee, and infinitely many rupees. Each time you win the game, you get a 1 rupee. You may get 2 rupees, 3 rupees. So in the pocket you may have, you said today you have a 0 currency with you, and you want to play a game. You won the 1 rupee, one rupee in your pocket. You play second game, you win again, you get a 2 rupee. Third time you win, fourth time you win, and you keep on playing. Theoretically, you may play as many times as you want. So your state space is what? 1, 2, 3, infinity.
Yes.
If you continuously play the game.
Mm-hmm.
So state space could be infinite also. Need not be always finite.
Right, sir.
So in this case, coming back to the good question again. So please stop and ask me questions like that, or any question you have in your mind.
Excuse me, sir.
Yes, ma'am. Yes, ma'am. पूछिए.
सर जो टेम्परेचर है वो कॉन्टिन्यूअस भी तो ले सकते हैं ना, कि इतने से इतने डिग्री तक, इतने से इतने डिग्री तक भी एग्जिस्ट करता है. देन हाउ कैन वी राइट इन स्टेट स्पेस?
हाँ, क्या होता है कि अब गुड क्वेश्चन अगेन. मान लीजिए पेशेंट जब एंटर होता है, कोविड पेशेंट, किसी भी पेशेंट हॉस्पिटल में एंटर होते ही उनका टेम्परेचर ले लेते हैं. सर ले लीजिए उनका टेम्परेचर है 100 डिग्रीज एट द टाइम ऑफ एंट्री, एंड देन एक दिन के बाद जब डिस्चार्ज हो जाते हैं उनको फिर 100 डिग्रीज तक पहुंच, मे बी वाई एक्स एंड वाई मे बी सेम, मे बी फिर 100 डिग्रीज हो गया, उन डिस्चार्ज हो गया, और मे बी 101 डिग्रीज डिस्चार्ज हो गए. सो 100 to 101 डिग्री. इस एक दिन में 100 to 101 में बीच में they might fluctuate between the 100 to 100.1, 100.001, 100 point something, 100.00001, and then end of the one day 101, or in between 101 again come down to 100.5, again went back to 101, है ना, ऑसिलेट हो सकता है.
यस सर.
तो इसका मतलब है कि पेशेंट जब एंट्री पॉइंट से एग्जिट पॉइंट तक 24 आवर्स ऑब्जर्वेशन पीरियड में उनका टेम्परेचर है वो फ्लक्चुएट हो रहा है.
यस सर.
तो फ्लक्चुएशन हो रहा है मतलब एग्जैक्ट, बोलिए.
Here it is written that X is the lowest temperature and Y is the highest temperature, not the initial and the final.
हाँ, लोएस्ट टेम्परेचर व्हेन यू मींस पेशेंट जब एंटर हुआ 100 डिग्रीज में एंटर हुआ, and then y means exit 101 में हुआ है. Suppose this is hypothetical. Suppose patient 101 दिन के बाद 101 हो गया, discharge हो गया, without discharge also still fine. Your observation is only stochastic model you are building for first day of a patient. मान लीजिए आपका कोविड पेशेंट है, देश भर में कितना कोविड पेशेंट है, उनका एक दिन का ऑब्जर्वेशन यू आर मेकिंग, बिकॉज यू नो दैट फॉर एग्जांपल द ट्रीटमेंट्स आर गिवन बेस्ड ऑन द फर्स्ट डे ऑफ द रेस्पॉन्स. दिस हाइपोथेटिकल.
How will we describe lowest and highest temperature? मतलब lowest temperature कितना हम describe करेंगे कि इतने से इतना होगा, इतने से इतना होगा, तो और highest को कितना करेंगे, वो तो कितना भी हो सकता है.
हाँ, कितना भी हो सकता है. हाईएस्ट मतलब हाँ, कितना भी हो सकता है. दैट्स डॉक्टर डिसाइड्स.
बट
X
सर
is the
अगर
entry time.
मान लो कि है ना टेम्परेचर 100 है, ठीक है, 98 नॉर्मल है, 100 है तो भी वो हाई है, 1 भी हाई है, 2 भी हाई है, then how can we decide
हाई
ना?
लो इसका मतलब नहीं, ये बुखार वाला हाई लो नहीं है. ये हाई टेम्परेचर लो टेम्परेचर मतलब लोएस्ट इन अ सेंस बिगिनिंग. हियर इसका मतलब है कि बिगिनिंग एंट्री हो गया, एंट्री टाइम का टेम्परेचर.
Okay, that's what I want to ask. That it is the initial and the
I
final.
can change. If you want, I can change this as a entry. Entry.
Yes sir, please.
Sir,
Ah.
sir, I just wanted to clarify the same thing related to this. Here, in this example, you have given hourly basis. So we have 24 recordings of the temperature. Out of those
24 recordings.
Yes, sir. Out of those 24 recordings, you have taken whichever is the lowest as the lowest. And out of those 24 recordings, whichever was the highest at whatever time period within those 24 hours, you have taken it as highest.
Yes, we can take that also.
Yes, I also want to say that.
Yes. So 24 time steps, we can take a lowest as a entry time, or the out of 24 hours, what could be the entry lowest level of the 24-hour observation. Very good. That could be also taken as, but then the main point is the point that I want to convey here is state space having a continuous values. Temperature continuous change हो रहा है उधर. आप मेजरमेंट करो ना करो, लेकिन टेम्परेचर का जंप जो है वो कंटिन्यूअस हो रहा है ना. That you are all agreeing that temperature is changing continuously. It's not changing discretely. You are measuring it every 1 hour.
सर ये इसको ऐसे भी क्रिएट कर सकते हैं, जैसे हम बीपी देखते हैं, हमारा जो मशीन होती है हाई और लो भी बता देती है.
हाँ,
तो वो भी एक एग्जांपल सेट हो सकता है यहाँ.
हाँ, correct. BP or temperature, these are all the state space, the values are changing continuously, है ना. लेकिन द टाइम आप जब देखोगे आपका मर्जी है, आप 1 घंटे में देखो, 15 मिनट में देखो, आधा घंटे में देखो, आपका मर्जी है.
ओके.
तो टाइम स्टेप जो है x0 एंट्री टाइम, हॉस्पिटल जब एंट्री हो गया पेशेंट, x0 उसका वैल्यू ले लीजिए, x1 15 मिनट के बाद, x2 आधा घंटे के बाद, x3 45 मिनट के बाद, x4 1 घंटे के बाद, और हर एक घंटा लीजिए, जैसे के साथ 24 बार लीजिए, हर घंटे में एक बार. आपका चॉइस है, डॉक्टर का चॉइस है, मॉडल का चॉइस नहीं. डॉक्टर का वैल्यू, डॉक्टर आपको बस वैल्यू दे देते हैं कि इसका इंटरवल ये है पेशेंट का, जैसे कि 98.4 डिग्रीज टू 102 डिग्रीज चेंज फ्लक्चुएट हुआ, हर 15 मिनट का वैल्यू ये है ना. तो इसका आप क्या करेंगे, दिस टाइप ऑफ थिंग्स, योर स्टेट स्पेस इज द थिंग व्हाट एक्चुअली अवेलेबल, कंटिन्यूस हो गया. पिछले वाला एग्जाम्पल में क्या हुआ, स्टेट स्पेस इज डिस्क्रीट whereas the time is continuous. Here state space is continuous, time is discrete. So this is known as discrete time continuous space model. कैसे मॉडल बिल्ड करते हैं वो हम हमेशा we'll learn that, we'll model solution, model building, all this we'll see. But then the type of models we are discussing, the अलग-अलग type of models which are needed. This kind of stochastic model is known as stochastic model with a continuous state with discrete space. And the previous one, if you recall just quickly, this first model is known as discrete time, discrete space. Second model is discrete space, continuous time. And third thing is discrete space, continuous space, discrete time. So this is called continuous space, discrete time stochastic models, depending on the data. So as a model builder, you should not have your opinions on what you like, what you dislike. What is the realistic data available? You should not compromise on that. So we main one of the fundamental things of a model builder is never compromise on the actualities. What actually happening on the ground level, never try to compromise on that. Try to build that as much close to the reality. So in this case, you may want to build a discrete time, discrete space model, but that won't work here in this case. This is someone told a good example of blood pressure. Someone told temperature, heartbeat, or the ECG values. These are all space is continuous, time is discrete. And fourth example is stock market values, share value within a day. So this is again a discrete time. So within a day, each day, every 1 hour you measure, but the share value of a share, stock value, that changes continuously. So again, discrete time, continuous space model. And our last value example, I think, about the level of water in a water tank. You in your home, in a bathtub, or in the sink, in the wash basin, anywhere you see, or in a tank, on the overhead tank, on the about the building, about the apartment, the water tank. You want to level of water and the time interval. So this is an example for in a time interval, the level of water. Again, that level is a continuous, highest and lowest lower value, like your blood pressure and other things. And the time is also continuous. You measure within an interval. You fill the tap, you open the tap, and then you want to measure the level of water within an interval time, within an hour, within a 4 hours, within a 1 hour, whatever time interval you set it. This is an example for this continuous time, continuous space. So far, that means 4 type of models are there. This is important. A quick summary of the things, 4 type of models, examples we saw. The stochastic models could be discrete time, discrete space, discrete time, continuous space, discrete time, discrete space, discrete time, continuous space, discrete space, continuous time, continuous time, continuous space. So any stochastic model in the world, will you take any kind of experiment, any kind of things, all will come under these 4 categories. There is no other category. इसलिए स्टेट स्पेस, पहले स्टेट स्पेस का अंडरस्टैंडिंग बिल्ड करना बहुत इंपॉर्टेंट. यू नीड टू बिल्ड अंडरस्टैंड. That means state space building means the doctor would not know, or the physics would not, or chemist would not know. If they know, that's fine. What I'm saying is, as a modeler, it is your role to decide iska state space kya ho sakta hai. So you need to check with the doctor if it is the BP, if it is the water tank, or civil engineer, or whatever, the who are conducting the experiment. You need to decide as a modeler, iska jo natija hai, outcomes kya ho raha hai. Iska jo state space hai, that is taking, whether we are naturally, without compromise, I like it, doesn't matter here. No, what is really happening is the state space. So building a state space is first very important. Then how frequently you are measuring. So in a time interval 0 to t, your x0 is the beginning level of water. X1 could be, need not be after 1 minute. You define your choice. X1 could be after 5 minutes. X2 could be after 7 minutes. X3 could be after 9 minutes. These two need not be any routine, need not be same level of length of the interval need not be same. आप अपना measure करते जाओ.
इसमें सर,
हाँ बोलिए.
प्लीज वो 4 मॉडल्स को रिपीट कीजिए सर. जस्ट नेम.
Sure.
Repeat कीजिए.
First type of model, example 1, discrete time, discrete space. Model stochastic model, discrete, both are, see, 2 things, 2 words, discrete and continuous. उसका ही flip कर रहा हूँ इधर उधर. Discrete time, discrete space. Why not I create a slide here? sorry. Okay, so these 4 kinds of stochastic models are there. Any model you build, that will fall under one of these categories.
Okay, sir.
Good. Now, as a last example, I mean, the previous one also I covered the continuous time, continuous model, but then Brownian motion, which will also, if time permits, we'll see that this example for a continuous time, continuous space models. A special kind of example that is, but then the previous water track example is given. That's very much enough. That's more realistic, more practically meaningful. Water tank example here. I provided that. Sorry, where is that? Yeah, water tank example. This is a level of water measured in an interval, and the level is a continuous, time also continuous. So the stochastic process is continuous time, continuous space. So any type of model you build in the world for any type of situation, be it physics, be it chemistry, be it biology, any medical situations, anything, that has to come under one of these 4 categories. Okay. There are also some mixed processes. There are exceptional cases. Once you are clear about that thing, मान लीजिए आप एक्सपेरिमेंट कर रहे हो and then in between you decided that you have to change it, like you have started with the discrete time steps, but उसके बाद आपको मेजरमेंट करने के लिए आपको टाइम नहीं मिला, आप उसको छोड़ दीजिए, आप you made it a continuous time, which are very rare occasions. So this is called a mixed process. उसको आधा टाइम स्टेप्स डिस्क्रीट हो गया, आधा कंटिन्यूस हो गया. So it is again comes under one of those 4. That means half of the model is a discrete time process, half of the time is continuous time. Half of the model will have continuous time. That means you could not continue the experiment, which is a rare case. You started the experiment, you could not finish the experiment, so you cannot measure it continuously. So partly discrete, partly like measuring the body temperature hourly basis, and then night time, we don't want to disturb. पेशेंट को एक्सपेरिमेंट कर रहे हो इसलिए पेशेंट को उठा दिया मिडनाइट में, नींद से उठा दिया, मैं नहीं एक्सपेरिमेंट के लिए उठो. नो, यू लेफ्ट रात 10 बजे सुबह 6 बजे तक एक्सपेरिमेंट करते. सुबह जब पेशेंट जगा है, अब कंटिन्यूसली आप डिस्क्रीटली मेजरमेंट ले लिया टेम्परेचर, और कहीं हार्ट पेशेंट है उसको मिडनाइट उठा दिया पेशेंट नींद से एक्सपेरिमेंट के लिए, उनको उठा के वी डोंट मेजर द टेम्परेचर्स, उनको सुबह मेजर कर देते. दैट मींस होल नाइट the experiment is the ECG recordings are done continuously from the patient, but we don't disturb the patient. So the half of the experiment is done with a discrete time measurements of temperature, and then night we left it continuous. So partly discrete, partly continuous. Then after that, so any doubts on so far the 4 type of models? If not, we'll go to the next step, that is transition matrix. Again a technical term, transition. उसका नाम से पता चलता है कि ट्रांजिशन मतलब ट्रांजिट, चेंज हो रहा है, ट्रांजिट है ना, यहाँ से वहाँ ट्रांजिट कर रहे हैं हम लोग, ट्रांजिशन. सो ट्रांजिशन इज अ ट्रांजिट मतलब बदलाव, चेंज हो रहा है, नाम से पता चलता है ट्रांजिशन. सो समथिंग इज चेंजिंग. व्हाट इज द चेंज? लेट अस सी क्या हो रहा है. द मैट्रिक्स, क्यों उसको ट्रांजिशन मैट्रिक्स बोलते हैं. सो लेट अस डिनोट अ मैट्रिक्स P एज अ ट्रांजिशन. नोटेशन पहले सीख लें, उसके बाद हम लोग एग्जांपल पे आएंगे. लेट P बी डिफाइंड एज P इक्वल टू Pij I कामा j बिलोंग्स टू j इज स्टेट स्पेस. कुछ स्टेट्स पे आपके पास है Pij, इसका सीखते हैं नोटेशन पे ध्यान दीजिए. अभी Pij, I इज अ स्टेट, J इज अ स्टेट स्पेस. सो I ए स्टेट, इसका एक स्टेट है, J भी एक स्टेट है. Pij स्टेट है. Pij इंडिकेट्स प्रोबेबिलिटी स्टेट I से स्टेट J पे जा रहा है, ट्रांजिशन हो रहा है. मतलब मेजरमेंट आप कर रहे हो किस टाइम पे I पे था, टेम्परेचर जे पे जा रहा है और स्टॉक मार्केट का वैल्यू आई था जे पे जा रहा है, पी आई जे. So this kind of probability transitions we cannot conduct in the simple probability, like someone asked a question about the sample space versus the state space. Sample space में transition नहीं कर पाएंगे हम लोग. Sample space बताता है कि total values कितना क्या क्या values outcomes क्या क्या हो रहा है, लेकिन transition matrix is thing in the stochastic process. हम लोग stochastic process पे ही सीखते हैं. Transition मतलब stochastic transition matrix. Values कैसे change हो रहा है, उसका probabilities क्या है. That means probability a patient admitted in the COVID patient whose temperature is certain degrees, उसके बाद उसको temperature उसको कोरोनिल या बाकी दवा कुछ दिया गया, उसके बाद after 1 day what will be the temperature, paracetamol whatever this thing intervention given, temperature change हो रहा है. So IJ, PIJ stands for probability of value of a state from I to J. These values are either zero, change नहीं हो रहा है, मतलब patient has not improved or not changed, the same temperature रहेगा एक दिन के बाद, or that means zero, no transition.
So here, here I and J have to be discrete only. They cannot be continuous, as I understand. Am I correct or wrong?
No, I mean I cannot say wrong to you because it could be depending on situation. हम लोग as we discussed this PAJ 4 type of models, I comma J. If you J you treat as a discrete, I comma J are discrete. If J treat as continuous, I comma J are continuous. Like temperature example. Any time, I didn't say time here. States only changing. Time के बाद हम लोग नहीं कर रहे इधर. Change इसलिए notation पे ध्यान दिए सब लोग. Change क्या हो रहा है? The states are changing. So you're right. In a sense, you're right. If the J is discrete, I comma J are discrete. If J is continuous, I comma J are continuous. लेकिन आप पिक कर रहे हो कुछ वैल्यू इनसाइड द टेम्परेचर इज कंटिन्यूअस बट यू आर पिकिंग ए वैल्यू 98.4 से 100 जा रहा है, द ट्रांजिशन हैपनिंग, but 98.4 98.4 100 both are part of a some continuous state space, it could be, है ना. लेकिन the two different times you are picking two different temperatures, so this is they are moving from one value to other value. So Pij is zero when there is no transition happening or there transition happening. There are only two possibilities. That's why the probability of transition is zero or more than zero. So Pij is a transition probability, जैसे अभी डिस्कस किया. So it is notation wise, आप यहाँ पूरा ध्यान दीजिएगा this पे Pij. This notation very very important. We will keep on using this notation rest of the course. इस पे ध्यान दीजिए. एक मिनट. तो इसको क्या हुआ? This is state. Time. तो टाइम इक्वल टू सम वैल्यू. तो इसको मैं क्या लिखा, लेट मी राइट डाउन द थिंग व्हाट एवर बिकॉज आई रोट दैट. सो xn प्लस 1 इक्वल टू j, कुछ स्टेट है xn प्लस 1 गिवन दैट दिस इज ए गिवन. इसका मतलब है यहाँ जो मैं स्लैश लिखा उसका पढ़ते हैं गिवन. गिवन दैट xn इक्वल टू i. इसका जो प्रॉपर्टी एक इवेंट है, इसका बोलते हैं इवेंट. दिस इज एन इवेंट nth टाइम स्टेप. इसका जो है टाइम स्टेप है, ये लिखा टाइम है, टाइम वैल्यू सॉरी यहाँ एक मिनट. इसको ये दिस इज द टाइम, ये टाइम है, दिस इज द टाइम एंड दिस इज j वैल्यू. तो इसका जो प्रॉपर्टी, ये एक इवेंट है xn इक्वल टू i इज एन इवेंट. xn plus 1 is an event equal to j. This is an event. इसको एक event बोलते हैं, इसको एक दो event है. But this event, given that this event, ये event हो गया already, xn already nth time step. xn plus 1 is इसको next time step. xn equal to I, xn plus 1 equal to j. This is known as conditional probability, or probability that xn equal to j, given that, given, इसको बोलते हैं given. Given that xn equal to j, conditional probability, उसको, this notation is, we write it as Pij. Notation पे ध्यान दीजिए everyone. So which is time? In this notation, this is the time. This is xf. That time is a random variable. This is a time. This is a state. Again, this is a random variable. This is time. This is state. Three things are involved. उसको notation. This is a notation. Notation को क्या है कि important in math or stat. We all know that notation is very important. Notation कुछ नहीं है. Notation just language है. Language का simplification is a notation. Notation that becomes an integral part of a math. So कुछ नहीं है. But लेकिन आप everyone please write down if you are notes आपको मिल जाएगा. लेकिन if you have pen and pencil there in your desk or wherever you are learning, or if you are using the notepads or tablets, use your pen and the stick there on the screen to write down something. But आप उसको ध्यान दीजिए क्या इस पे, which is the what is it called now, which is the state, what is the state, what is time, what is random variable, these three. So this is so far हम लोग क्या सीखे हैं, उसका जो final summary, the summary point is that we reached a important notation so far, transition matrix. Let me save my slide. Yeah. So this is the last. इसके बाद हम लोग will stop for the today's lecture because I know it's a long day already for you all. For me, it's a fresh day, morning day started, but I know understand. But I'll start with this is the last slide for the day. So if Pij equal to 1, summation over j, see all states I, अब किसी स्टेट से शुरू कर लीजिए, उसके बाद j, all the states equal to 1. If equal to 1 in a transition matrix, we say P is a stochastic matrix. इसका मतलब है, again, let me, 3 states, suppose you take a matrix here, 3 states are there, 1, 2, 3, 1, 2, 3, 3 states are there. Suppose your state space S equal to 1, 2, 3. So probability P11 means probability with the experiment, it starts with the first x1 equal to 1 and again x2 equal to 1. Iska probability. This is equal to, we write P11. मतलब x1 experiment शुरू किया, उसका value 1 ले लिया, then the outcome is 1. x2 again 1, P11. Similarly, P12, this second value of a row, starting from 1 to P13. Similarly, P21, starting from 2, again going back to 1, P22, P23, P31, P32, P33. So अगर इसका रो वैल्यू P11 plus P12, that is P11 plus P12 P13 equal to 1. That means I fix I to j. For each I, if Pij equal to 1 means for each I, अब I मतलब each state I 1 से शुरू किया, this is equal to 1 and P21 plus P22 plus P33 equal to 1. Similarly, P31 plus P32 plus P33 1. If these are all 1, 1, 1, 1, each row, sum of the values of the probability is equal to 1, then that is called a stochastic matrix.
I have a query here.
Yes, please.
That by imposing this first constraint, are we not making the things very much certain? Are we not telling that it is necessary to make a transition? It is transition from the state I to any other state in the which is the element of the state space. So my point here is that can't we include here a fourth state, which is basically an uncertain state, just to include more uncertainty and remove the certainty from the first constraint?
Well, here the P11 means probability of transition from state 1 to state 1.
Yes, so here it is mandatory that we need to make a transition from 1 to itself, or 1 to 2, or from 1 to 3, because the sum has to be equals to 1. And now this has eliminated the possibility of the uncertainty that I denied to make a transition. So how
Yeah,
to
no need.
incorporate that?
No need. इसको मान लीजिए आप कॉइन टॉस कर रहे हो, है ना?
हाँ,
इससे भी और थोड़ा सिंपल एग्जांपल लेंगे, दैट विल बी मोर. मान लीजिए आप हेड टेल, आप इधर हेड टेल लिखा है ना?
Yes.
आप इधर लिखिए PHH PHT.
Yes.
इधर PTH PTT लिया, ठीक है? मान लीजिए आप 2 बार एक्सपेरिमेंट किया, आपका एक्सपेरिमेंट आप बस 2 ही बार आप कॉइन टॉस किया, है ना? Suppose you can define your experiment. This is hypothetical. So your experiment is tossing a coin 2 times.
Right, sir.
Then first time heads मिला आपको. First experiment that is say x1 equal to h and x2 equal to say h.
Yes, that's true, sir. But this does not include the possibility कि मैं toss करने से मना ही कर दूं. मतलब I do not flip the coin.
हाँ, वो stochastic experiment नहीं है फिर. मतलब आप experiment नहीं किया, मतलब that you cannot include that in the state space anyway.
Okay. I hope that we are using two terms, stochastic and randomness, here interchangeably.
Correct. Here, what happens in this case? Let us finish our x1 equal to h, x2 equal to h. Then, in this case, what happened? What is PHH? 1.
1, yes.
है ना? Because second time भी h मिल गया, and आपका experiment finish हो गया. Isn't everyone following that? If your experiment is what? मैं लिखने रहा हूँ time उसका लिए, इसलिए what is experiment? Tossing a coin 2 times, measuring the outcome. बस आपका experiment उतना ही है. Then first time h, second time h. Then p, what is the p value of p? इसका value pht. इसका value कितना है? 0. Because h to t transition नहीं हुआ, h से ही transition हुआ. Because outcome first time h, second time h. Third value, इसका value pth compute करेंगे. pth कितना हुआ? pth means probability of first time toss tail हुआ क्या? नहीं. So इसका value 0 है. ptt इसका actual undefined, मतलब this is in a way not defined. Probability transition t equal to never happen. First time आपका head, first time you toss a coin, you got a heads. Similarly, ptt also you cannot measure. You get probability t to t. So this is, so you have all values. In a way, this is so 1, 0, 0, 0. And this is not a because this row is 1, but here this row is not 1. Some of these values undefined.
Yes.
Now suppose in the 2 experiments, now you include another, you extend your model by saying that I will also include 4 times, 2 more tosses. So then x4 equal to x3 equal to again say t, and x4 equal to t. So उसका मतलब x2 के बाद x3, h to t आपका मिल गया, फिर something else again t to t, you got some values here. So that's how you fill that matrix. And if that row sums are 1, then if this if is important here, it's not always true. If agar ho gaya, agar the summation of each row is 1, value of each row is 1, each that's important, each also is important, each I, that means each value of that, this is a h, each I means each of these value, agar h se shuru hua, h to all other values, h to t, t se shuru hua, t to h, for each of that, each of the row, this is equal to 1, this is all are 1, then you say stochastic matrix. If the columns also 1, that means doubly stochastic.
Okay.
So everyone, please focus up to this slide as of today, and we'll continue tomorrow.
Hello.
And if you, this is the end of my part. I mean, feel free to ask any question throughout the whatever 2 lectures we
Am I
learn.
audible, sir?
But very important, don't skip any doubts in your mind. Don't leave anything in your mind. Okay?
Am I audible? Hello.
Yeah.
Hello.
Excuse me, sir.
Yes, पूछिए.
In your second row, जो अभी आपने example explain किया है, there is sum of row is not equal to 1.
Yes.
Why?
Sum of row not equal to 1, it is not a stochastic matrix.
Okay, sir.
Every row sum is equal to 1. That's what the definition here. If j belongs to j, that means j is a value of the j is a state. For every j belongs to every j, pij equal to 1 means यहाँ देखिए p11 1 to 1 1 to 2 1 to 3 और कोई ऑप्शन नहीं है. अब 1 से शुरू किया, इधर 1 to 1 रहना है और 1 to 2 1 to 3. There is no other option. आपको escape नहीं है इधर. अगर each row equal to 1 is a stochastic matrix, किसी भी 2 रो, इसमें 2 रो 1 हो गया, तीसरी रो 1 नहीं है, then it is not a stochastic matrix. Each row summation of the values probability is equal to 1.
Am I audible, sir? Hello.
It is stochastic matrix. Yes,
Can
audible.
Yes, sir. Can I ask something, sir?
Yes, please.
Sir, in the definition of that P matrix, the definition is Pij, where I, comma j belongs to the capital J, right? The state space.
Correct.
But J state space, you were saying that it can be continuous, right?
Yes.
Okay, so let us consider that the J is equal to 99, 101 interval. Okay, and I is the ith row and j is the jth column, and Pij is the entryth of the ith row and jth column, right?
Correct.
Right. So if I is equal to 90, and the interval is 99, 101. So if I equal to 99.9 and jth is equal to 100.1, then the ith row is 99.99th row and jth is 101.1th row. So isn't it sound absurd that some rowth number is 99 point something and column is 100 point something? Isn't it sound absurd?
No, because the same rows, whatever the state space, मान लीजिए continue, let me draw here. It's a good question again, let me, wait a minute. Still you can see can you see the screen?
Yes, sir.
Okay, suppose let me here, this is an interval, so here, continuous interval. The state space here, the states you write like that. So each state, any value, that means any value to any value you want to draw here, or you are in this case, you example 99th row, here 99 row, and there's somewhere here say, let me erase this and make a 101th row. I know. So this is that means here this particular here 101th row also must be there somewhere here.
Yes, sir.
101th row. So 99 के रो में जो है उस पे लिखेगा P99 101. For confusion to avoid, we write a comma here.
Right, sir.
So that means P9. Let me write in a bigger font. P99 comma 101. That indicates. Sorry, that indicates probability that.
Probability of going 99 state to 101
state.
Right, sir.
अगर आप इसको define नहीं कर पा रहे हो, that means it is you are not building a matrix properly here. You have to define each value should be defined. अगर इसको define नहीं कर पा रहे हो तो इसका जो outcome है you are unable to measure it. That means you are not conducting experiment completely. The values which you cannot compute, you cannot anyway have a stochastic matrix. I mean, you cannot have a transition matrix anyway. So transition matrix has to be built first. अगर आप इसको वैल्यू नहीं लिख पा रहे हो, एक्सपेरिमेंट आउटकम नहीं है, that means you are not able to form the previous stochastic matrix, the previous whatever you learned here. This is not able. We are unable to match. Once you form a stochastic matrix, transition matrix, then there must be some value here, है ना? Some value. You have some value small x, or say that is a small
no, sir,
px.
I'm asking about probability of 99.9 goes to 101.1.
Okay, 99.1. If you define 99.1,
right, sir.
Then that also that 99.1 to 101 has to be measured.
How can you interpret? But how can you interpret the 99.1th row? How can you interpret that? Pij means ith row and jth column, right?
No, in that case, continuous. That is a continuous state space, not discrete state space.
J. You were saying that in the definition of P, that is Pij, I comma j belongs to J, capital J, where J is the continuous state space, right?
Correct.
So if that is continuous, then small I and small j may take values 99.9 and 101 point something, right?
Just a notation here. What I meant, this is a notation here.
Excuse me.
For I comma j could. Sorry.
Excuse me, sir. I think here I and j need not be numbers as in the previous example, head and tail.
Correct. I could be if the I comma j belong to j is a continuous, then I could be a value of a real number within that value, within the j, the temperature, any 99.1. So that means 99 point, when you measure it, 99.1, the value there, that jump, it could be any value. Near 99.1, we have to have, ultimately we have to define that properly, then only we could able to measure the probability there.
Right.
So when we learn the more and more complicated models, you'll see that this is also possible. 99, that means when you are unable to measure something, that won't be part of the matrix anyway.
Right.
So I comma j continuous means continuously you measuring, that means you suppose 99.1, when you randomly take a measurement of the patient when admitted in the hospital, the temperature is P99.1, which be value, whatever the value. Then again, when you randomly measure another time 101. So what is the transition probability of that? Because at random point 99.1, another random point 101. So transition हुआ ना फिर.
Right, sir. हुआ.
And then how to compute that probability, we will again discuss that. That's a different thing. But the transition, first you understand what we are trying to understand the transitions here. You fully clear or partially clear?
Okay, sir. Clear.
Fully clear?
Yes.
Good. Thank you. Good. So like that, I would like to be this kind of lively thing should happen, and don't leave anything. Don't keep any confusion in your this thing. So if you are,
sir, may you share your?
Sorry, sir. Sorry.
Sir, may you share your slides in group?
Acha, abhi you are. My slide is not shared now. Can you see this? All of you see the screen?
Yes, sir. It is visible.
Yes.
Yes, we will share all this PPT once the program will or in between the program. Okay, Dr. Sweeti.
Okay, let me.
I think they are asking for to share your PPT with them.
हाँ, एक मिनट है, मैं स्टॉप शेयरिंग. हाँ, तो you want the each day slides to be shared with you end of the day?
Yes, because that will help us to revise the things for the next day.
Absolutely, I love this idea. तो मैं
Yeah.
प्रोफेसर कुमार, आप क्या बोलेंगे इसमें? प्रोफेसर डॉक्टर रेदू.
ठीक है. Okay. Yes, sir. You can share with us. And
तो मैं प्रोफेसर कुमार आपको भेजूंगा, आप दोनों को.
Okay. We'll transmit it to the other participants.
Yes, please. That's a good idea. And we because एक कोर्स हम लोग तीनों डिजाइन किया.
Yeah.
आप सबको सिखाने के लिए. And
Because it will be very
enjoy the
beneficial
course.
for us.
Sorry, बोलिए. I did not listen to the question.
I think there is no query. Professor Rao, thank you very
sound
much
आ रहा है.
for having
बाकी
a very
भी mute कर
interesting
लीजिए.
session. In the first session or the session also, you started with a very fundamental concept, and hopefully
एक मिनट है. Everyone, please mute the screen. I can't listen it.
kindly mute. All are requested to kindly mute their mic. So my point is that this sessions taken by you are quite a good and fundamental, and I hope all the participants has enjoyed it. It seems that participants are, you see, going through this very consciously, and they are learning. That is the purpose of this course. And I have seen 3-4 participants has quite have raised their queries and have cleared their doubts. And you have very well explained that how we can move on slowly and steadily to have a depth of the knowledge of these basics. So hopefully in the few coming sessions we will be able to give training to our participants about the stochastic processes and of course their applications to different problems. I think all of you have enjoyed, all the participants. Is it okay? You see, you can also tell us that how we can have a better way. The purpose of this course is to just to impart training about this specific area of interest. So that should be fruitful. That is the only purpose we, from organizing side, I can assure you, that is the only purpose of us. Even our Professor Rao is very comfortable with all these things. And the aspect is at the end of this training program, you must have something to learn and you must have a future to work in this area. You can teach the course on this and you can work, you can carry out your research in this area. So that is our purpose and we can go accordingly. Of course, we can go very slowly and if you like, we can go fast and even we can have more tutorials. So as you wish, it is all with the wishes of the participants. The aim of ours is to have better training. So kindly cooperate and you can ask any doubt, any problem, any time. And see, at the end of, we will be happy that if all of you learn, you have a knowledge of stochastic processes. Thank you, Professor Rao. You are nicely started your this inning, and this will go a very long way, I know, very slowly, and of course, all the participants will enjoy it. I too, being a man from this area, but I am also enjoying, just clearing my basic concepts also. Thanks a lot. I thank my team here, Professor Dr. Poonam and Dr. Meenakshi, and all other my research those who are here with me and here center working station. So we are thankful to the organizing team and all the members who are joining over here, and a very you say enjoy the day. At the end of this day, you just have a rest, have a food, and in the morning and tomorrow only at the 4 p.m. In Indian time, And of course, Professor Rao have the very early morning. Will be here again on the board. Thank you. Thank you very much for all joining here and cooperating with us. Thanks a lot. Thanks,
6:15
Professor
we are
Rao.
meeting, isn't it, at 6 o'clock?
Have a good day, sir.
Tomorrow 6:15 or 6 o'clock?
Participant, actually, today lecture is also available on the YouTube channel. I will share you with you the link of YouTube, so you can also listen today lecture on that channel.
Sir, may I? 8:30. I'm Dr. Priyanka.
So we are at starting 6 o'clock or 6:15?
Okay, at 6 o'clock Indian time.
6 o'clock, okay.
Okay. Earlier we have lecture at 5 to 6.
Yes, sir.
And then thereafter there will be break. And 6:15.
5 lectures start 6, okay.
At 6. At 6.
Thank you.
Okay.
Thank you.
Thank
Nice to see you all.
Thank you.
Namaskar.
Thank you, sir.
सभी को नमस्कार.
Namaskar.
So is there any WhatsApp group for this course? Because I have not, I have not received invitation to join the WhatsApp group if it exists.
Your mic is not on, Dr. Poonam.
Okay. Rink is good.
Yes, yes.
You already.
You already added in the group. Okay. Can you please send me your WhatsApp number so that I can add you?
Okay. So
One
I'm
more thing,
sending it.
there is a test on the last day on 18th March from 5 to 6. So according to that, prepare your lecture and listen
So
that carefully.
I'm sharing this number with you, and you please
Okay.
include me on this number.
Okay, sure. I will add you. Yes. Any query from the participant?
So just now I have shared my number with you.
Okay.
Yeah.
Hello, ma'am.
Yes.
Hello, ma'am. Ma'am, can you provide the PPT and the recording of this session?
Actually, I will say YouTube link with all of you, and
Yes.
there you can listen all the lecture.
Okay. YouTube link WhatsApp ग्रुप पर आप डालेंगे?